Okay, so we talked in the last video about how to multiply polynomials together. We're going to make a transition now, and we're going to talk about how to unmultiply polynomials. This is not exactly the same as dividing polynomials. That's something we're going to do later. I know typically when we're solving equations and things, we think division is undoing multiplication. And in a sense it is. Those are inverses of each other. But what we're talking about right now is something a little more basic than this. And so we're going to go through a series of different types of problems where we're unmultiplying. And we're going to approach this from a couple different ways. In every situation, what I'm going to do is I'm going to show you a multiplication problem that you already know how to do. And then I'm going to show you a process that helps you to unmultiply that. Okay. These all fall into the category of factoring. So if that's something you remember from a previous class, that's the topic that we're going to be talking about, is factoring. And the first kind of factoring we're going to study in this particular video is factoring using something called the greatest common factor. Okay, so let's take a look at our learning objective, and then we'll get started. Only one learning objective: be able to factor a polynomial using the method of greatest common factor, or the technique of greatest common factor. Okay, so that's what we're looking to do. So like I said, what I want to do with all of these different techniques that we're going to learn is I want to start by looking at a type of multiplication problem, a specific kind of multiplication problem. And then we're going to talk about how this particular method of factoring undoes that process. Okay, so greatest common factor, what greatest common factor is designed to do is it's designed to undo a simple distribution problem. So we're going to begin by looking at a problem like we would have done earlier in our class, where we have just a nice, simple distribution process. Okay. So if we were to multiply this together, if we were to simplify this polynomial or expand this out, or whatever word we might use, we know that the method we're going to use is to distribute the 2x to both things in the parentheses. Okay, and what I want to do is I want to show an intermediate step that typically we just think about, but we don't write. However, this intermediate step is going to be important to the concept of factoring. So I want to make sure that it's right in front of us so that we can look at it. When I distribute the 2x in here, literally what I'm going to have to do is a 2x times a 3x. Now, usually we don't write that. We say it, we think about it, but we usually don't write it. And then I've got this plus sign, and I'm going to do a 2x times a 5. Okay, so that's what we literally mean by distribute, is to do that process right there. And then we would simplify by multiplying these things together. So I've got a 2 times 3, which is 6. X times x is x squared. And then a 2x times 5 is going to give me a 10x. And that would be my answer, and I would be done. Okay, so this is the process of multiplying in this direction. And we're doing the multiplication in the form of a distribution problem. Okay, so this is the first type of thing that we've got. All right, now what we're going to do right now is a factoring problem. And what a factoring problem is going to do is reverse this process. And in this case, we're going to factor using the greatest common factor is what we're going to do. So what you're going to see in these problems is, instead of starting with something that looks like this, this is going to be your starting point down here. And then you're going to have this intermediate step. And your final answer is going to look like two things that need to be multiplied together. Okay, so I think you can see from that idea what I mean when I say we're unmultiplying, because normally we would normally start here. We'd have an intermediate step, and this would be our answer. Okay, but we're going to have the exact same work in reverse. Okay, so let's actually do this particular problem so that we can talk about what I would be looking for and what I would be thinking about as I do this. So if I'm looking for a greatest common factor type problem, what I want to do is I want to find something that divides into both numbers, and I want to find variables that they have in common, if at all possible. So in this case, 6 is an even number, so I know it's divisible by 2. And 10 is an even number, so I know it's divisible by 2. Both of these things have x's, so I know that both of these terms could have been multiplied by something with an x. So my intermediate step is to write down that common factor that I recognize that both of these have. They both can be divided by 2, and they both can be divided by x. I'm going to just keep that plus sign in the middle for now. And then I also want to have what is it that 2x is multiplying by in each case. So in other words, 2x times what gave me a 6x squared. Okay, well, we know because we just did the problem, it's a 2x times a 3x. Okay, and a 2x times what would give me a 10x. Again, we just did the problem, so we know it's got to be a 5. Okay, so that would be my intermediate step. And then my final step, what I'm doing is instead of distributing something into the parentheses, I'm pulling this stuff out and putting it in front of a set of parentheses. So I'm going to have a 2x in the front, and then the stuff that's left behind is what will end up in my parentheses. Okay, so that's the basic idea. And you can see how the thought process is very, very similar. It's just in reverse. Here I'm sending the 2x into the parentheses. Here I'm taking the 2x out of the parentheses. Here I'm multiplying a 2x and a 3x together to get 6x squared. Here I'm trying to figure out 2x times what equals 6x squared. Okay, so it's the same kind of thought process. It's just in reverse. Now, one other comment that I will make, just like we normally don't show this intermediate step when we're multiplying, we usually do that step in our head. If you are comfortable to do this intermediate step in your head, you should feel like you have permission to do that. Don't feel like you have to write that step out every time if you don't want to. Okay, so this is the basic idea of factoring through the method of finding the greatest common factor. Okay, I'm going to make a second video with examples in just a second, but there is one other thing I want to show you before I wrap up this particular video right here. So some of us, to figure out what a greatest common factor is, not a big deal because we have done a good job of memorizing our times tables. But that's not true for all of us. Some of us, our times tables are tough for us. And so, and there's no shame in that. That was true for me back in the day. I've done math for a long time. I finally have started to know my times tables. But what I want to do with you is share with you a website, maybe. Here we go. Share with you a website that can help with this. Okay, so this is just a normal regular website. It's not, you can see that there is a paid version, but there's a free version also. The name of the website is just wolframalpha.com. Okay, so you can see that up here, wolframalpha.com. That's the name of our website. Wolfram Alpha, there's the title right there. And this is kind of like, it's kind of like Google for math nerds and science nerds. You can see it's got lots of math and science topics down here, and you just ask it a math question. So like in the problem we just did, we needed to find the greatest common factor between 6 and 10. So I can just ask it, what is the GCF, greatest common factor, of 6 and 10? And I can just ask the question, and it'll think for a second, and it gives me the answer. The answer was 2, and that's exactly the number that we ended up using. If I have bigger numbers, I can change this to be whatever numbers it is. What if it wasn't 6 and 10? What if it was 60 and 100? Okay. For me, that would be a hard problem for me to figure out, but my calculator or my computer, it figures it out very quickly. Okay, so Wolfram Alpha is a website that can help you working with the numbers in a situation where you might not know your times tables well. Okay, so that's an option that I just want you to be aware of. We will use Wolfram Alpha later in this chapter to do other things as well to help us with factoring. Because we're going to end up with numbers that are not always easy to factor, numbers that are not a normal part of our times tables memorization. And so there are going to be numbers that even if you are good with your times tables, you might not be able to work with them as well as you'd like. And so we're going to visit Wolfram Alpha again in this chapter to deal with those situations. All right, so that's the basic idea of what we're going to do in this particular section. In the next video, I'll just work through a handful of examples. We'll develop this a little further. I also, as we start looking through a couple of examples and we've got a few things that we can look at, I'll give you a little trick to help you find greatest common factors with variables. Okay, so Wolfram Alpha, that website, can help me find a GCF for numbers, but there is also a handy little trick that works with variables. And once we've got a couple of examples done in the next video, I'll show you what that trick is then. So make sure you watch that next video. Thanks for watching this one. Have a good day.